Okay, so chapter three is about protocols and the OSI models. Most probably, you guys have heard of OSI models in other modules. Uh, and also, you guys know about the protocols. So let's see what are the protocols. Okay, protocols are essentially set of rules, and just like human, when we communicated with each other, we have to follow certain rules. First of all, we should be able to speak the same language, and there are other rules of communication. Let's say not two people should be talking at the same time, right? Or not many people should be. This is just example of a rule of communication in a human being. So there are same way there are rules, because when on a network, when you're sharing resources, all the devices are communicating with each other. End devices, router, switches, all these devices are communicating with each other, so they have to follow certain rules. Okay, so let's watch this little video, because some of these videos are
This is how we see the network. Using topology diagrams, we can see the devices in the network, including end devices, such as desktops, and servers, and intermediary devices, such as switches and routers. These diagrams may also contain detailed information about a device, such as the MAC address of the Ethernet and wireless NICs, IP or Internet Protocol address information, default gateway addresses, and addresses for the DNS server. By the way, don't worry about what these terms and addresses mean right now. All of this will be explained throughout this course. This is how we see the network. But how do devices see the network? You can think of it as every device being in its own bubble. The only thing a device knows is its own addressing information. In other words, this is how a device sees the network. It doesn't. So, how does a device know its IP address and what network it belongs to? How does a device know if the destination device that it needs to send information to is on the same network or another network? If the destination is on another network and the information has to travel through intermediary devices, how does the source device know where to send it next? How does the source device know if the information it sent was received or if it needs to resend anything that might not have reached the destination? The answer to all of these questions is protocols, the rules that govern how devices communicate. Most network communications are broken up into smaller data units, which we can refer to as packets. When packets are sent on a network, many protocols are involved to help them reach their final destination, each accomplishing a different task. There are protocols such as Ethernet and wireless protocols that physically connect the device to the network. The protocols DHCP and ICMPv6 provide IP addressing information, including IP addressing that tells the device what network it belongs to, the address of the default gateway that tells the device where to send packets that are destined for another network, and the address of the DNS server for when a device knows the domain name of a destination but needs the destination's IP address. For instance, when a user requests a web page from a web server, such as www.example.com, the device asks the DNS server for the IP address of the domain name www.example.com. IP is used to deliver the packet from the source of the information to its final destination, in this case the web server, similar to sending a letter. The web server will then respond back with the requested web page. TCP is a protocol used to guarantee reliability. In other words, to make sure all the information that was sent was received, such as the information that makes up the requested web page. If any of the IP packets don't make it to the destination, TCP resends them. So, although we see the network like this, remember, it's a combination of many different protocols that allow devices to really see their place in the network and how to communicate with other devices.
So the key thing is, so we are not on a network. Most probably, sorry, you're most familiar with the TCP/IP protocol, but actually, in order to for all the devices to communicate with each other, there are many protocols. Different protocols are used. So it's not just one protocol. There are many different protocols. Okay, so now let's see, I'm gonna use the PowerPoint. Actually, okay, so yes, so in this chapter, we'll learn all about protocol, different protocols, suites, and the data encapsulation, which is important. Okay, so the rules. So, what are the communication fundamentals? There has to be a sender and there has to be a receiver. So there's a source, which is the sender, and the destination is the receiver. And also there has to be a channel, the media. So so in a network, one computer. So if you're accessing YouTube on the internet, okay? YouTube is and you're watching video, so YouTube sending the video. So YouTube server is the sender, you're the receiver, and the channel and the media in this case is complex. So there's not just one channel or the media, but there are multiple channels and media. That's why which is belong to different ISPs in the world, depending where the YouTube server is located. So this is also known as cloud because you don't know what's in there. Okay. So in your lab last week, you connected two computers. So sender, receiver, and the channel was the cable, Ethernet cable. A channel could also be in the wireless network. The channel is the atmosphere, the air. Okay. So the all communications are governed by protocols, the rules, and the rules are very similar. Human communication or in the network. So you have message, you have signal, which is the transmitter, the medium, you have receiver, message receiver, and the destination. So here is two computers with simple just connected to each other. So now individual has to understand sorry, they have to be agreed on rules. Okay, and on the network these communication is if the communication is not formatted properly, there will be a problem in communication. So the first message is difficult to read because it's not formatted properly. So I don't know if you guys, the example could be uh, ping. When you ping a device the first time, the first ping is lost. I don't know if you guys ever notice it, but yeah, and then after it goes through. So because the first time it's not formatted properly. So, what is the job of the sender? Okay, so sorry, what is the job of the protocol? So, the protocols, they identify sender and receiver, and how they identify sender and receiver by addressing. That's why you have to have IP addresses. Every device should be addressed, should have an address on the network, just like every house has to have an address identification. They have to speak, obviously they should speak the same language. Okay, speed and timing is also important for the message to send and receive. And also acknowledgement on the network is very important. Like, for example, right now when I'm talking to you, I don't even know if you guys are listening or not, so there's no acknowledgement. In this case, it's probably work, but on the network it could be a problem. So when you access a web server and the web server acknowledges or confirm that it received your request. So and the reason is important. So if it does not send the acknowledgement, you would not know that your request has gone through. Okay, so this is also very important on the network. Okay, acknowledgement, and you will see how they use acknowledgement. Also, message encoding is a technique to encode message in a format that can be understandable. Formatting and encapsulation means the all, because there are different uh, uh, there are different fields in a network packet. For example, there is sender's address, receiver address, acknowledgement information. Okay, all this information has to be encapsulated, like medicine are encapsulated in a capsule. Okay, so the same way all this information has to be encapsulated. Okay, also the size of the message, timing, and the delivery options. So these are all these are requirements of network protocols. So network protocols are very, very important in networking. So yeah, encoding is just the process of converting information in another form of transaction. Okay, so messages are encoded in one form, so both sender and receiver can understand. So at one point from the message is encoded, and at the other point the message is decoded. Okay, because the process is reverse, and you will see later on uh, what's included actually in the message, why there has to be encoding and decoding. So format also is important, just like letter. Okay, what happened when you send a letter? There's a format, or there's a rule that you have to follow. Your name, the recipient's name should be in the middle, and the sender's name and address should, or the information of the sender should be on top left corner. If you reverse it, what is going to happen? Recipient will become uh, uh, the sender, and the sender will become the recipient. Okay, and your message or envelope will not be delivered properly. So same way on a network, the format is important. How every information should be formatted, and the message format depends on the channel that are you using. Okay, for example, wireless, uh, copper media, different channel has their own method of formatting the information, and the encoding also uh, between host should be in the appropriate format, and the message size also is should be determined, meaning how big the message should be, and this is measured in bits. Okay, and obviously the receiving must should be able to decode the signal to interpret the message. So message timing, what includes the message flow control. So the rate of transmission should be determined. Like, sender should not send messages uh, uh, faster than the receiver can receive. Okay. The response time, how long the device wait when it does not hear a reply. This is also part of message timing. And access method, it determines when someone can send a message. So there may be various rules, okay, that are used on the network because there are so many devices are communicating with each other. Okay, and there are many different protocols. So who can access the media? So there is a rule for that as well, okay, that governs. So it's like we have rules, we have traffic rules for our cars to run on the streets. We have stop sign, uh, 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 traffic lights. The whole reason for this of all these rule is so the cars won't collide, there won't be any accidents, or the traffic flows. Okay, for same exact reason there are access methods on the network. So the communication, in this case these packets or signals, can uh, uh, can travel on the network without colliding, because just like cars on the network, these signals can also collide with each other, and that bring down the whole network. Okay, one of the common problem on the network is the network is slow. All of the sudden the network is slow. We cannot access either access to the internet is slow, access to your file server is slow, or the database server is slow. And how are you going to troubleshoot this problem? Problem is not always related to the server itself, where maybe the server has low memory, or servers is having CPU problem. That is not always the case. Most of the time, the problem is on the network. Okay, and that could be related to signals are colliding with each other, and that's why you need to know all this, the flow control, response time, because then you have to troubleshoot the problem, and you have to monitor the network. So for that reason, it's important to understand this access method and all access method, flow control, response time, all this. So So there are different delivery options on the network. So you have unicast, which is one to one, is the most common. Okay, when you're accessing a web server on the internet, is unicast. Okay, then there's multicast. Uh, so it's from one to a group of computer. Okay, more than one computer. So you see, source is here, and it's accessing two computers, communicating with two computers. There are four computer, and it's communicating to just two computers. This is called multicast. Okay. And then there's a broadcast. It's communicating to all the networks. Okay. Now, as a computer user, you don't get to decide that your most of your communication is unicast. Either you're accessing a server, web server, or you're sending somebody email. This is mostly unicast. If you're sending bulk email, right, that could be multicast. That's an example of, because I'm sending to the group. So as a user, actually is the protocol or application that decide if the communication is multicast, unicast, or broadcast. Okay. So some protocol they use broadcast. So as networking professional, it's your job to make sure that if the application is designed to send messages as unicast, okay, it's sending it properly. So that's why you need to know the difference between these three messages. Okay, so these are, you see these icons? So this is used for broadcast, this is used for multicast, and this is unicast in your course, okay? All right, so network protocols. Let's see how many protocols you guys have. So can be implemented in devices, either both software, or on the software, hardware, or both. Protocols have their own function, the format, and the rules. So each protocol, so you have different protocols. You have network communication protocol, okay, you have network security protocol, you have routing protocol. So that's what you're going to learn later on. What are the routing protocols? uh, that's what, when you're configuring the router, remember, so far you have configured the passwords, you assign name to the device, and the next step is configuring configuration of routing protocol. Okay. And then you have discovery protocol that discover devices on the network. Okay, so there are different type of protocols for different functions. And all the devices, they have to use the same protocol in order to communicate. So for example, I don't know, Apple Talk has, the other computer has to use Apple Talk. Apple Talk is, by the way, is a protocol, as the name implies, of Apple. So same way, if one device is using TCP/IP, other device also has to use the same protocol, TCP/IP. And one of the thing, and so these are the things that protocols are responsible for. Most importantly, addressing. Okay, so they identify sender and the receiver. They also provide reliability on the network. Okay, flow control, that data flows at efficient rate. Sequencing, So how they provide this how they provide one of the way they provide reliability is technique by using sequencing technique. So they use the sequence number to track packets. Okay, they can also detect error. Okay, and they can also process communication between network applications. That's what they do. Now, this is amazing. You For me, this was amazing for me when I was learning about all these protocols and all these processes. The communication between two device is established, or it's, well, depending on the speed, it happens in nanosecond. But there are so many things that are being used, hardware, software, different techniques to make this happen. Okay. So for us, we just, when we go to the web browser, it takes seconds to access the web page. But how many things are involved to make this happen is just mind blowing. Okay. So many techniques, protocols, devices, softwares, not just one software, different software. And but okay, so each network requires the use of several protocols. So when you use when you go access a web server, how many protocols are you using? Uh, it's not just one protocol. There are different protocols that you use. By the way, TCP/IP. I'm sure you guys by now you guys know that TCP/IP is not just one protocol. It's a combination of different protocols. It's a suite of protocols, and each protocol has its own function. So, for example, on the web server, on the internet, you're accessing the website, so you use HTTP, that's for sure, right? Hypertext protocol. You also use TCP, which is for transporting your message. IP protocol provide addressing. It's responsible for addressing, and the Ethernet protocol. This is the Ethernet protocol dictates how your computer will communicate to your router end, your end of the internet. And then after, you see, the cloud means it's the ISPs and uh, it's the ISP network, and then it goes to the web server, your request. So these protocol are essential for uh, to establish a connection on the internet. So yeah, the protocol must be able to work with other protocols, and for that reason, there are a combination of protocols, and each protocol uh, uh, has its own function. Okay, so there are higher level protocols and there are lower layer protocols. Higher level protocols doesn't mean that they're high in functionality or anything. It's just they work with software. Okay, higher level protocols, and lower layer protocols, they directly work with the hardware. That's why they are categorized. So let's see how many. So you guys have probably know about these protocols, the suite and their, especially TCP/IP suite of protocol and their functions. So HTTP, you have DNS, GHCP, FTP. You guys heard of FTP, File Transfer Protocol? So this protocol is used in Cisco devices to back up your configuration, to back up your iOS image. So that's what you will do when we in the lab. How to use FTP server to back up your configuration. Okay. Then, so these are called application layer protocol because they mostly they directly deal with, they're the software, and they directly deal with, they're more closer to the user, they're more software based. Okay. Or you can, they deal with the application that user are interacting with, like for example web browsers. Then you have transport protocol. Think of transport protocol as trailers or trucks. Their job is to carry your signals. Your signals, think of your signals are as goods. So they're the one who that are responsible to taking your message from source to destination. And these two protocols in TCP/IP suite of protocols is the responsibility of TCP and UDP. Okay. Then you have Internet Protocol, for example, IP version 4, IP version 6, ICMP, which is messaging, and then you have network access layer, the bottom protocol that directly deals with the media, with the connector, with the cable itself. It it deals with ones and zeros that are that are being sent on the wire. And then you have different there are other protocols. It's not just TCP/IP, it's just TCP/IP is the most popular protocol, is the protocol of the internet. I don't know if you're working in a real Apple network with only with Apple devices, you will probably see Apple Talk protocol. You will work with Apple Talk protocol, but most probably not. Okay. And Novell Netwear, I don't know if you guys have ever heard of this. They were the biggest network Novell operating system about 20 years ago. I don't know how they, and they had their own protocol, SPX, IPX. Okay. But obsolete. I don't know they still exist. So these are the example of TCP/IP protocol. So application layer name. So you have hypertext. HTTP is the application layer protocol. TCP transport, and IP, which is internet. And then you have Ethernet. Ethernet is the most common local area network protocol. So in the local area, when devices communicate with each other, they use Ethernet. That's why it's called Ethernet card or Ethernet switch, because they use Ethernet protocol. And what is an Ethernet protocol? Is just how the device communicate with each other. It dictates, it sets rule. Well, we already, I know you guys already know all about TCP/IP. Okay, so yeah, it's the network. It's a free protocol. It's used on the internet. And one thing probably you guys did not know, all these protocol uh, uh, that are part of TCP/IP suite. You have HTTP on the web. Uh, for file transfer, it's FTP. Email, you use SMTP protocol, and then for host configuration, it's DHCP. So there's DHCP4, DHCP6. Is there any protocol that you guys have never heard of? Then you have internet layer. What is net? NAT. Do you guys know what net is? Have you guys heard of this? Not NET, NAT, network address translation. Anyway, so the network address translation, it translate one IP address to, sorry, it translate private IP addresses to public address. Okay, and then here you also see some routing protocol: OSPF, EIGRP, BGP. So routers, they have their own protocol to communicate with each other. What is the job of the router? Is to route packets between different network, and they use a routing protocols to do that. Routing protocols, remember, are only used between routers. They're not used on devices and devices. Okay, and devices use TCP/IP to access the router, and then the router talk to each other in order to find the best path by using routing protocol. And these are just three example of a routing protocol. There's more. Okay, and that is you are going to learn how to configure routing protocol on devices, in this case Cisco devices. And these are ARP and Ethernet and wireless LAN. They are the lower layer protocol, access layer. They deal directly with physical devices. So this is TCP/IP communication look like. So a web server encapsulating and sending a web page to a client. So it adds all this information. Ethernet. It uses Ethernet to add the Ethernet frame. What is an Ethernet frame? It has MAC address, source MAC address, destination MAC address. Then there's IP that adds IP information. Then you have TCP, which uses a transport method. So all this information is encapsulated. Then it sends it to on the wire. You see, and this is the client. Here's the client, and then a client de-encapsulate all this information. On the wire, it sends as ones and zeros. They travel as ones and zeros. So from web server to the client, so web server encapsulate all this information, meaning put it together, and then the client de-encapsulate, because it has to learn about the IP addresses, message type, all that information. Now, standardization. Okay, in engineering standardization, we use uh, standard, so the products from different vendors can work together. Okay, like for example, there's a standard of this USB. Okay, USB port. What if the size is different of this USB port? All the manufacturer, they agreed upon the size of, I don't know how many millimeter or inches it is. If they don't agree upon the size of this the USB port, a port from one vendor would not work with with other vendors' computer, because they're using different. You would not be able to insert. So this is just an example of why there's a need of a standard. So in the network, you have device. First of all, you have many different devices, hardware devices. You have many different softwares, and they all have to communicate with each other. So if there's no standard, a network card from, let's say, D-Link would not. So you have a net on one computer, you have a network card from D-Link. On another computer, you have a network card from Netgear. Okay, And if there's no standard, those two devices would not be able to communicate with each other, because maybe they're using different techniques, different signaling methods, different encapsulation. Okay, so that's why standardization is important in network communication. And you have different organization that sets the standard. One of them, one of the most prominent, is IEEE. It's not just they're not only deal with network communication, but any type of electronic devices. That's why it's called IEEE. Oh, by the way, it means Institute of Electronic Electrical Engineers. Okay, so this is one of so when you're buying, so let's say if any of you decide to start making your own network card, so you should, so for that, to do that, you should follow the standards. Okay. Then there is Internet Assigned Numbers Authority. They assign, they deal with the IP addresses. Then you have Internet Corporation. So all of these, they are just non-profit organization, and they deal with they set standards. Anything that has to do with network communication. Okay. So the standard, so these are different. You can read it on your own. This Internet Society, IAB, Engineering Task Force, they're all deal with the internet. Oh wow, they have increased over the year. There were not many in the beginning. There were just one or two, but now you have many, because internet has become really huge. So there are more, so more and more organization are required to control, I guess. And these are different organization: Institute of Electric and Electronics Engineer, very telecommunication. TIA is exactly is important organization, because they also deal with cables. Okay. All right, have you guys ever heard of OSI model before? Okay, so what is an OSI model? Since the network communication is so complex, many devices are used to to make this happen. So if you see, there are two networks. So this is one network, and this is another network. You have different devices in each network. You have end device, which is the desktop. You have a server. You have a switch, and then you have an IP phone. So different devices using different softwares. Then you have routers that connecting to these two networks. So router is also a different device, a unique device. And on the other end, you have same. So the goal is to make communication possible from this device to this device, from this network to the other network. So there are many, as you see, there are many different protocols that are being used. There are many different software that are being used, and there are many different hardware that are being used. So it's very complex. So to make this more easier to understand, to make this process easier, the whole process easier to understand, they divided this all the process into layers. Okay. And they divided into 7 layers. Each layer deal with a specific process on the network. So you have application layer. So there are 7 layers. First of all, application, presentation, session, transport, network, data link, physical. So each layer deals with the specific uh, 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 job or the task on the network. The top layers mostly deals with software only. So the top four layers until transport, they deals with the software. For example, transport only handles TCP and UDP. Okay, then you have session layers. They deal with HTTP protocol, DNS, DHCP, FTP. Okay, and then the lower layer protocols. Starting from the network layer, uh, they're more involved in hardware. So network layer deals with the routers. Okay, data link mostly with switches, and physical layer with cables and connection. So the purpose of using this layered model is just to simplify the whole process. It's easier to understand, and also for the vendors when they manufacture devices, they so if you're manufacturing, let's say, a switch, okay, so you have to comply with data link layer. Okay, so that's what it means. Remember, OSI model, because a lot of people get confused with OSI model. It's not a software. This is not something you can see on the computer. It's not a hardware. This is not something you can touch. OSI model is just a reference. It's just a way to simplify or explain the network the network process or communication process between devices. Okay. Now, since the popularity of the internet, they modified OSI layer, and they call it TCP/IP model. And what they have done is they did not add anything new or any newer layer. It's just they combined some of the OSI model layers into one layer. So they combined application, presentation, and session layer into one application layer. And then the transport is still transport, network layer is called internet, and they combine data link and physical layer into network access. Okay, so this is the TCP. They do the same thing. The both layer is just TCP/IP is has less layers because uh, 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 some other layers are combined because they do very similar tasks. For example, application, presentation, and session perform the similar tasks, so they're merged into one layer, which is application layer. So there are a lot of benefits of using layered model. It assists in design that that operates at a specific layer. Faster competition because products from different vendors can work together. That's the biggest advantage of OSI layer. So you have different vendor in early days of networking. When you buy, for example, when you buy servers from IBM mainframe, and other vendor has better, let's say, memory card. Okay, but you cannot buy that memory card and use with IBM machines because they were not following the standards. It would not be compatible. But because of OSI layers, it so devices from different vendors can communicate with each other. Okay, and it also prevents if there's a change in technology, okay, in one layer, it would prevent changing the other layers, and also provide a common language, okay, function and capability. So that's what OSI layer is. don't think it's a software that you can operate, or it's a hardware device. It's not embedded. It's OSI layer is in everything, from your computer to the cable to the switch to network card, connectors, software. So one of the layer of the OSI is being used with all in all aspects of your computer functionality. So these are the different layers, and this is what they do. So application layer, okay. So it contains protocols that are used to process communication, okay, between devices, presentation for it used between application, session, also it used to manage data exchange. So yeah, these are different protocols, and they deal with different devices. Data link used with the media, for example, cables and the network cards. Also, physical layer also deals with the cable. Okay, network layer deals with usually the router and IP addresses. Well, a segment here, a segment means a piece. Okay, so when you're sending a data from source to the destination, the data is sent. The data is broken into different segments, and these are called packets. Okay, segmentation is important, or it's useful because it increases the speeds and also increase efficiency. uh, like for example, if you want to it's easier to send smaller packets from one source to the destination than sending a huge or big container. Okay, so that's why this whole communication between sender and user, it's broken into different pieces. Like think of these pieces as envelope. Okay, so that's the purpose of segmentation. It increases the speed and also increases the efficiency. Now, if if your whole communication is broken into pieces, and you can see each piece is represented as an envelope, okay, what if one of the pieces is gone missing? How are you going to reconstruct the whole message? Okay, so for that reason, every packet or every message is numbered, and they follow the sequence. So like 1, 2, 3, 3, 2, 1. So if one is missing, okay, the sender can resend the same packet instead of sending the whole message. So sequencing is responsible for that. So this is example of encapsulation. So it's a top-down process. It starts from the top, okay, from the application layer. It adds different information into the packet. Okay, so once it's encapsulated from the source, here is being encapsulated, and at the destination, it's de-encapsulate. So it starts from the bottom. Ethernet receives the frame, and then it look at the IP address, the TCP/IP segment, and finally it sees the data. Okay, so the whole process is decapsulate. Addresses is important. There are two type of addresses on the network that are being used. Okay, you have Ethernet address and you have an IP address. Ethernet address is an address that is burned onto your network card. Okay, so you have to have this address. Just the IP address is not enough. So when you communicate on the network, you're actually using both IP and the MAC address. Okay, MAC address is data link layer is responsible for the MAC addresses. That's why they're also called the data link address. Okay, and your network layer is responsible for the IP addresses. Okay, IP addresses is a software based address. Layer three, since it's a software base, is also called logical address, and you guys already probably know that every layer three address contains both network ID and the local computer ID, right? So each packet on the network requires the both source IP address and the destination IP address. So you see, this user is accessing the network. A packet contains the source IP address, which is his own IP address, and the destination IP address. So this is what a packet looks like. This is what's inside the packet. Okay. One of the field is the source, and next one is destination, and then you have other fields in the packet. I don't know. So each IP address contains the source, sorry, host portion and the network portion. So the device knows if it's in the local network or the remote network. Okay. IP version 6, you will learn later, has it's a bigger, it's a longer address because it uses more bits than IP version 4. But it's still IP version 6 also have both source and the source and the network portion and the host portion. When devices are on the same network, they use the MAC address. So when the devices are on the same network, they use the source and the destination number in the network portion, and they're not, the packet is not sent to the router if it's in the same network. But when it's in a different network, the packet is sent to the router. Then the router decide how to send this packet to its destination, choosing the best route or the fastest route. Okay, so when the device wants to communicate to any computer, okay, so what happened is your computer, your software, TCP/IP, look at the destination address, and it matches with the network portion. It matches the network portion of the address to its own IP address. If the address is the same, it send it to its destination. If the network ID is the same, network portion ID is the same, it send it to that network. If it's on a different network, it sends it to the router by using the default gateway. Okay. And they also use the MAC address, physically embedded address on the network. Now, when packet goes through the router from one network to another network, the source MAC address changes. It changes from the original MAC address to the MAC address of the router interface. Okay, So this information is important when you're troubleshooting networking problem. Anyway, all this information all that is presented to you, it's it's used when there's a problem on the network. Okay, once you set up the network, your job is to monitor the network to see to make sure nothing goes wrong. Okay, and this is what you have to monitor. So if the device is on a remote network, I already explained, it goes to the router, you see. So the PC1 is communicating to the web server, which is on a remote network. Okay, it's not in the same networks. So the packet goes to the router, and then it goes to another router, and finally it arrives its destination. So it goes from network to network. And when it goes from one network to another network, okay, the source MAC addresses changes. But the IP address never changes. So if you see, the source IP address will stay the same. Only the network address changes. So when the web server receives the packet from PC1, it will still receive the source IP address as 192.168.1. Okay, but in the case of MAC address, it the MAC address changes to the last the address of the interface, router's interface. So yeah, so in the different networks, data link address, as I explained here. So this is, they're talking about the same thing. The MAC addresses changes depending on the router, but on the local area network, it never changes. So remember that the source IP address changes. The source MAC address changes when it goes through from one router to another router. Okay, so in this, I don't know, we have a class tomorrow on the, uh, sorry, in school. So Wireshark is a program. Why do you need all this information? I just tell you before. Once you set up the network, I don't know if you guys, once you set up the network, what is your job? You're not going to be creating users and groups every day. You're not installing new application every day as a net admin or even a tech support. Uh, the job of the tech support is, if there is a problem, you have to fix it. So your problem could be with the user, with applications. Uh, for example, if the application is not installed properly, if there's a hardware problem on a computer, maybe hard drive crashes, you have to fix it. But then there are a lot of problems because everybody use network. Everything is done on the network. You have centralized servers, not just using the internet. In companies, they have database servers, file servers. They collaborate, like multiple people work on the same spreadsheet. So there are multiple people working on the same using Excel, and they are collaborating. Okay, so the network is being used all the time. So, and if the network is down, many people cannot perform their duties. Okay, so once you set up the network, your job is to monitor the network all the time. Okay, to make sure that the user can do their job. They have uh, 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 access to the network with reasonable speed. To do that, you use software network monitoring software. One of them is called Wireshark, very popular software. And the best thing about this software is free. It's open source. There are other software, the companies. There are other products that are that you have to purchase. Solar Wind and Network Inspector, oh, many other products. Sniffer, okay, is one of the product that is used to monitor network. So now what we are going to do is we're going to install Wireshark in school in the lab, and if you want, you can install on your computer as well. Okay, it's a very so the purpose right now. The purpose is just to give you a bit of introduction of Wireshark, like to get familiarized with the interface. Learning Wireshark is complex. You need to have more knowledge of the network. Okay. So don't get overwhelmed, don't get confused or frustrated, because that's not the purpose of this course to make you expert in Wireshark. This is just the beginning. It's just so you can understand, okay, how the network monitoring is used to troubleshoot network problems. So if your network is down, you probably have to use this network monitoring software to find out if the problem is with the network card or with the switch or with the cable itself, and that's when you use these programs. Okay, so we have labs about where. All right, so this is like there's a lot of theory in this chapter. People think that this is something that you don't need to, because you're not doing something with this OSI layer or data encapsulation or data access. But trust me, you need this information to troubleshoot network problems. Uh, some of you guys, all right, so this is the end of this chapter. Okay, so I'm going to stop recording.